Hey Internet, Gordon with PCWorld here. I'm with Dr. Ian Cutress of Tech Potato. By the way, go over to his channel, click that like and subscribe button and smash that bell. But I have Ian here because I want to discuss Zen 4C. What is Zen 4C and how does it compare to Zen 4? What do I need to know? I, as a consumer-focused person, don't pay too close attention to it because it's not here yet. What the hell does it? Is it just Zen 4 with a C on it? What's the difference here?
So I've just come from AMD's data center and AI innovation event, which was just held 10 minutes up the road from these guys' studio. So I thought I'd come by. And one of the major announcements there was their enterprise Epic platform, currently running Zen 4 platform, just like we have in consumer. But they've now introduced what they call a cloud native design based on Zen 4 that they're calling Zen 4C. And a lot of people have been predicting whether this cloud native design is kind of like Intel's E-cores, right? So AMD right now does not have a P-core, E-core strategy like Intel does. They haven't gone hybrid that way. And there's been a lot of rumors in the press that this Zen 4C design, which is Zen 4, but again, optimized for cloud, whether that could be the effective low power efficiency core that the consumer market may be used for. And as part of this event, they kind of said, well, here's our new enterprise Zen 4C only product, which they're calling Bergamo, 128 cores, 350 watts, fits in the same socket as their standard Epic. But they also gave us details on what the core actually is. Because Intel P-core and E-core, we understand the architecture the microarchitecture is different because they're optimized for different design points, but they're fused together in an individual system. Zen 4 and Zen 4C, if you were to run a program on Zen 4 and Zen 4C, it would essentially look exactly the same because the architecture is identical.
Huh.
The only thing they've changed, the only thing architecture they've changed is the L3 cache. So instead of having 2 megs per core, we now have 1 meg per core, which most consumers won't see a difference with anyway. But what they've done in order to fit more cores in the same space is they've gone back and looked at the physical design. This is when you take your architecture, microarchitecture, and actually implement it in silicon. If your design point is a 5 gigahertz consumer CPU, you have to essentially build out your design in silicon to make sure that it hits 5 gigahertz. So there are implications with your keep out zones and interference and induction and power. It's very complex in order to build a very high frequency part. We've seen this. It's the reason why we don't have 10 gigahertz processors today. However, if you limit those guardrails to say, I only want to hit 3 gigahertz maximum, you can do a lot of design optimizations, and in this case, a die area to hit that. So I think they said, instead of 3.5 square millimeters for a Zen 4 core, it's now 2.5 for a Zen 4C. Now you do lose that 1 meg of L3 cache, right, but the rest of the core is anywhere from 35 to 50% smaller. But if you compare 3 gigahertz to 3 gigahertz, you're going to get the same performance, minus the cache. It's effectively the same IPC, but you do get power efficiency, and you do save in terms of manufacturing and die cost. Now, they call this Zen 4 dense, which is Zen 4D, which makes everything complex externally. But AMD right now, their enterprise lineup is either all Zen 4 or all Zen 4C. Intel's doing this in enterprise as well. But the reason why I wanted to speak to you is this question of whether Zen 4C will come to the consumer market.
Right.
And I don't think it will. At least this generation.
So what is that? You mean, so we won't see Zen 4C necessarily in a hybrid design?
No.
But we might see Zen 5C if we were to make up something.
Yeah. This was essentially a trial run for AMD internally in terms of their engineering design. They obviously have cloud customers who want the core density, and so they ultimately designed it for cloud in mind. And that's why they have guardrails and they can make it so far dense. They just launched the SKU list for this enterprise part, and the base is something like 2.1 gigahertz with turbo up to 3.1. 3.1, maybe 3.4, 3.7. But they did say with this design, because they've made it so small, if you try and push it harder further up the frequency line, it'll be less efficient than Zen 4.
Huh. Okay.
But it will be more efficient below kind of 3 gigahertz, which people might say, well, that's perfect for an E-core, right? I don't think that was designed for hybrid in mind. AMD still hasn't done a hybrid CPU.
Right, because they're all, your current Ryzen parts are all big.
Yeah,
right?
yeah, and the whole point about the E-cores, P-cores and E-cores, is that you can fit roughly 4 E-cores in the size of a P-core. Now, Intel's P-core is a lot bigger than Zen 4, but Intel's E-core is a lot smaller than a Zen 4 C-core. So you can't necessarily make that migration and call that, I would guess, a win.
Right, because, you know, obviously they would still stick with the chiplet design probably,
Yeah,
right? So
yeah.
they'd mix sort of Zen 4 with 4C, but then as applied to consumer desktop,
Yeah.
is that really going to get you enough to beat what Intel's doing with their hybrid?
If you've got space to put a chiplet down, it's probably best to put 8 Zen 4 cores.
Right.
The chiplets between Zen 4 and Zen 4C are roughly the same, except in one you get 8, the other you get 16. Again, the question is, right now the I/O dies are built essentially that you have a homogeneous design, not a heterogeneous design. You don't have a mixed match of cores. Every core is effectively the same performance. But they are very well aware of the hybrid ecosystem that's being developed. And obviously, Intel has things like Thread Director that they're developing.
Right.
I'm not even sure that AMD will quote quote have access to that, or because it's an Intel defined specification with Microsoft. Microsoft will have hooks that I think AMD can use, but AMD then has to go design their own variant that goes on top, speaks to the core, speaks to the CPU. They're very well aware of it. The design teams are very well aware. I just think for this generation specifically, it wasn't the target, but
But not, I mean, but the other question I think a lot of consumers are going to have is like, does AMD even really need a hybrid design? Because there's definitely a lot of people, naysayers say, well, it's a little weird on Intel because you have these P cores that are really different than their E cores. There's not an AVX 512 in the E cores, which is why they largely had to shut it off in the P cores. Doesn't it make more sense? Why does AMD need to even pursue that in a consumer-sized socket versus a server?
Yeah, there's a lot of people thinking along this line that they don't want AMD to miss out, fear of missing out, FOMO. But to your point, based where AMD is in terms of their client roadmap, their client SKU offering, at least in desktop, there doesn't seem to be that need to have this differentiation. I mean, even if you had, say, an all Zen 4C part in mobile, do you really want your mobile processor to be limited to about 3 gigahertz? You don't. You still need the high performance cores in there. And that's going to be a hill that AMD will have to climb at some point, I think. As much as I'm not a fan of hybrid designs, I think I've made that very clear on this very channel. It's something that could happen in the future. You design a core to a specific design point, whether it's frequency, power, die size. They call it PPAC, power, performance, area, cost. You've got to make sure that it fits into that. And as we use more advanced process nodes, cost is only ever going up. So you need that balance.
Yeah, and the thing I always saw Intel's hybrid approach is that's what they need to do to win some of the marketing wars, which is like we need to have more cores. We need to have a bigger performance number, which for Intel that got them with their hybrid design because honestly they were on a 10 nanometer process, let's be honest, and by jamming in those E-cores, they could get much higher multi-core performance and compete with AMD, which was on that more efficient TSMC process. But I don't know if that applies for AMD, right? Where's that math? Do they need that, I guess?
You remember when we first tested the hybrid E-cores, not in Lakefield, but in actually the desktop parts, and we said, well, these are actually the same performance pretty much as a Skylake core, right? Yes, it's a 6-year-old core at this point, but it's still a nicely high-performance core. The gap between AMD's cores is going to be a lot smaller, right? So, it's you could. I'm going to get these chips in on the enterprise side. It's very funny seeing a 128 core, 256 thread chip and you put 2 of them in a system.
Wow.
I've seen screenshots of 512 threads in the Linux equivalent of Task Manager. It's insane. In order to see them all, you have to have a 4K screen and go to font 2 size font. And I have requested to install Windows so I can run Cinebench. Because you got to really. But no, we're going to get an idea of how these cores perform at the frequency that they're built into these cloud-based chips, and we can do the extrapolation to how that may be on the consumer side. The only thing we can't extrapolate is the nature of what a hybrid design will bring, and how threads are managed between the 2 cores. Again, it's a hill AMD has to come up to at some point. But I don't think it's this gen. And we've seen rumors that they may come this gen. And but items get added and pulled from roadmaps all the time. And in this era of the higher cost of production now for these chiplets, it's becoming more and more apparent that they like to try lots of things, but what gets commercialized, is a very small subset of that.
Yeah, and then to me, as a sort of raw performance guy, their performance is already, even though you're looking at a 24-core Intel part versus an AMD 16-core part, other than some benchmarks that might run better on Intel, there's definitely a lot of multi-core performance, even though they have fewer cores that AMD, because they have all big cores, they're still outperforming Intel. So I don't see that either this generation, because it just doesn't seem like it would make sense, because why would you, unless you're getting more performance everywhere, it doesn't seem like they're going to get that gain you would expect.
It's if we look at the desktop CPU from AMD and we replace those 2 8-core chiplets for Zen 4 with 2 16 Zen 4C core chiplets, which, there's a few reasons why that won't work with the current I/O die, but if we just take that as, it would work, then you've got to think you've now got 32 cores in that socket. You've still got the same amount of memory, still got the same amount of memory bandwidth. Right. You've actually got 2 CCXs per CCD, so there's actually some additional communication. How does the I/O scale as you put in that many cores? And again, if you're limited to 3.1 gigahertz, realistically as your performance metric, would you replace your 7950X 16 core with a 32 core version at almost half the frequency?
Yeah, no, I mean it's that fine balance of,
you still want the responsiveness of the high performance cores, right?
Right.
Of a hybrid design.
Well, you still get that though. You'd get that out of the. Oh, you're saying replace all of them?
Half and half.
Yeah.
Half and half?
Yeah, it's half and half is
that gets you closer to the hybrid design.
Yeah. The question is, I don't think the I/O die is built for that right now, especially on the consumer side. Again, something they'll have to design in and then have the software stack to support it.
Right. So a lot of questions, but Zen 4C, interesting. Probably not going to apply to us anytime soon, it looks like.
It does have simultaneous multi-threading. E-cores don't.
It's actually
just leave on that.
Yeah, I mean, again, so that comes down to the internal modeling and testing that AMDs can do, because maybe the math works out like we're just giving you 32 cores in a consumer desktop. I mean, true consumer desktop, not Threadripper.
Yeah.
And that performance may actually be worth it for some people.
Yeah.
If you need that core density in a consumer desktop.
If AMD was going after the Core N, the Atom line, the N300, those sort of 8 Tremont cores, you could put 16 Zen 4C cores in. They'd be insane, but sure, why not?
Huh, okay. Well, hopefully we'll learn more information as we see where Zen 4C goes. Again, Ian's going to probably get some of these Zen 4Cs on the big iron, on the big stuff, not the toys that we play with down to consumers. So, of course, if you want to see that coverage, go to Tech Potato, like and subscribe and smash that bell button. Of course, come back to PC World's channel for more PC coverage.